All right. Okay, it started. Now,
Daddy,
what?
So is there a solid thing on the periodic table?
Yeah, a lot of things are solid. Most
So
things.
that's everything that doesn't have a liquid sign, a gas sign, or a radioactive sign?
Yes, if they have a little sign like these two little things, they're gas.
But if they don't have a sign, then that's a solid.
And if they don't have a sign, they're a solid. You're right.
Okay.
So most of them are solids.
What is radioactive?
This is Chem.
Okay, I'll teach radioactivity in a little bit. Let me show you the periodicness, or the
This is Chem what?
of the. This is Chem 6, is it?
This is Chem7.
7. Okay.
Say it.
Now this is Chem 7. Here's the things we want to review a little bit. Atoms are small. Atoms are almost empty space. Atoms are made of three things: protons, neutrons, electrons. The electrons are whizzing around the outside, the orbits, at insane, incredible, ridiculous, unimaginable speeds, being basically everywhere at once. So they consider them in a cloud or a shape, but there's nowhere they know exactly where that atom is at any one specific instant. What?
Can the electrons go around there as fast as light? Can they go as...
No, they're not as fast as light, but light is the fastest thing there is in the universe. So if you're
No,
going
closer
2%
to
the speed of light, you're
You're going
insanely
fast.
fast. Yeah, you're insanely fast. Light is 186,000 miles a second, 300,000 kilometers a second. Miles per hour don't even make sense with light. It's miles per second. So
What about miles per millisecond?
it wouldn't even make sense. A millisecond, 100,000th of a second, still, we're talking fast. Light is fast. Again,
Fast.
remember when I told you that light is so fast that, remember when I told you atoms are so small we really can't even comprehend it? We just have to sort of
Light
chew
is
on it a
so
while.
fast, you can't comprehend.
Yeah, light is so fast we can't even really comprehend it. Okay?
It's super
But it's fast.
Fast.
But these electrons are going so much faster than a bullet. So much faster than. And the thing about it, the atom is so small. Now, if light could go this far in a second, and there are gazillions. It can take gazillions of trips around an atom in a second. So light doesn't even. Electrons don't even have to be that fast to get around that atom. Basically, and be everywhere at once. They're everywhere around that atom in 1 second. And so that's where that's why atoms seem solid, That's why that's why your butt doesn't fall through. I have the electric charged electrons negatively charged here, electrons negatively charged here, whizzing around. The negative and negative repel each other, and I can't push the boards through each other, even though the boards are almost all empty space. Isn't that incredible? Does that blow your mind?
So, Dad.
Does that blow your 4th grade mind?
Daddy, so what if you took something super, super skinny and put it, and why couldn't you put that through?
Something super, super skinny?
Yeah.
Because it'd still get hit. What if I had a helicopter with its propeller going as fast as it could, and I took a BB or a little bitty piece of dirt clod and I threw it, what would happen? Probably the blade would hit it anyway.
Yeah.
Okay. Or a blender. Take the blender and you still try to stick a little tiny wire in it. It'd still get hit. Okay. Now, these electrons are moving 1,000,000 times faster around that atom than the blender that your mom made a smoothie out of. Okay? And you would never put your finger in a blender because you're going to get hit by the blades. Even though in between the blades is mostly empty space. Right? That's why these atoms are. So anyway, I hope you understand that. That's why that gets important for physics. Now, the periodic table is set up when you can draw an atom, you can sort of start to understand why atoms act the way they do. Let's draw this fluorine atom. This is atom number 9. Let's see what we do. I'm going to draw fluorine. And then now, before you do anything, whoa, hope that will work. I don't know where they get that little, oops, there. Okay, before we draw fluorine, I want some predictions. What row is fluorine in?
Where's fluorine?
F.
2.
So it's in row number 2. How many shells is it going to have?
2.
And since it's in row number 2, and it's how many over? 1, 2, 3, 4, 5, 6, 7, 8?
It's gonna have.
1, 2, 3, 4,
No,
5,
it's gonna have 7.
6, 7. Yeah, I messed that up. It's going to have 7 in its second shell, right? It's going to have 9 protons and 9 electrons.
Yeah.
And actually, most of the time it has 10 neutrons, but that number's not there, so that's kind of a bad thing. But anyway, let's draw fluorine. I'll draw a fluorine atom. It has 9 protons. It does have 10.
Fluorine?
I'll explain that in a second. It's an element. Any of these are just elements.
I know, but what like does it look like?
It's actually a liquid, and it's like a. It's a
Wait,
very.
there it says it's a gas.
Does it? Oh, you're right. I thought it was a liquid. You're right. It's a gas. Oh yeah, fluorine gas. I should have known that. I wonder what temperature it turns into. Room temperature, but I think it can turn to a. Okay, wait a minute. So it has 9 protons, 2 electrons. That's dang it. And it has 1, 2, 3, 4, 5, 6, 7. Now watch here. This is what's important. There's one big empty spot. So fluorine is 1 electron away from being filled. Fluorine, electrons, atoms want to have filled shells. They want to be stable like the noble gases, even though it isn't like they want to be royalty. They just, and they don't even want it, but they act to get their shells filled. You got it?
So every atom wants to get its shell filled. Basically.
It's going to try to fill its shell, yeah, because that's a more stable configuration. And here's the deal. It's not that they want to, they're not thinking about it, but you could think about it. If I hold this board up like this, is it going to want to fall like that? You could say, well, it's going to want to go to a more stable configuration.
But
if I
does
put,
it want, it's not alive.
yeah, it's not alive. So I wouldn't say they want to, but they will act. This board will fall here, and it'll be more stable that way. Atoms are going to be more stable with their filled shells. You got that? Fluorine is going to do stuff to fill that shell. It's going to be an electron grabber. It's going to want... Is it easier? Because it wants a filled shell. It could either get rid of all 7 of these. Is it easier to move 7 things or to move 1 thing?
1 thing.
Yeah. So fluorine is going to try to steal electrons and grab them. Then it's going to have 10 electrons and 9 protons. Okay, and then it's going to have a charge. And this is where the chemistry gets fun and interesting. If you understand this basic thing, you'll understand everything. So this is fluorine, all right? It is a very powerful electron grabber because it's 1 away from being filled. Look at this. So is chlorine. So is bromine. So is iodine. They all want to grab an electron. Oxygen wants to grab 2. Have you ever heard of something being oxidized? Rusted? That's because it grabbed the electrons. Oxygen wants to grab 2. Nitrogen will grab 3. Carbon could grab 3, 4, or it could let go of 4. So carbon can go either way. Looky here. Let me draw lithium.
Wait, so something has to, so if we have electrons, we have to get our and my question doesn't make sense.
It's worth finding that out.
Dad,
What?
while you have that erased, can I draw something?
You want to draw something? Now let me draw this and then I'll show you that. This is lithium. You see that? It's going to want to give away that electron and go down to a stable thing of a filled shell because 2 fill up the shell. So everything in this column wants to give away 1 electron. Everything here wants to give away 2. Everything here wants to give away 3. Everything here wants to give away 2 or 3. Now this is, everything here is going to want to take 1. Everything here
It's full.
is full and is fine. It doesn't want to deal with anything else. It is stable the way it is. So now, see, you don't have to memorize anything. It would be impossible for me to say, okay, there's 100 elements. You memorize how many electrons they give, how many they take, if they're going to react, are they going to conduct electricity, how many shells they have, how many electrons in their outer shell. That'd be impossible, right? Chemists don't have to do that. They just look at the periodic table. They go like this. Oh, it has 3 shells. 3 and it's a third shell. It's going to be a metal. It's going to, slightly conduct. It's not. Boom. I know everything.
Okay.
Just by its position in the periodic table. By knowing the position of an atom in the periodic table and being able to use the periodic table as the ultimate cheat sheet, you now know everything, what's going to happen. That's
Okay.
lesson number, what was this, 7?
I think
This is lesson 7. Come back for 6.